So this is another nonlinear system of equations. And this one doesn't line up nicely. I know there's 2x squares, and we probably could do this by system or elimination, but it's probably easier just to do substitution because y is by itself over here. So that's what I'm going to do. So I'm going to substitute this y equation into that position in that first part of the system. So this is going to give us 2x squared. Since I'm going to substitute into y squared, I'm going to give it a little space, make sure I keep the square, and keep it equal to 10. So I'm copying down the exact same equation, it just wherever the y was, I'm putting an empty set of parentheses. And inside that parentheses, I'm going to put what y is equal to, which is this 4 minus x squared. So let's expand this out. Remember, we have to write it twice, and we're going to FOIL it, but I'm just going to do it in my head. So this is 2x squared. 4 times 4 will give you 16. You're going to get negative 4x squared twice, so that'll be negative 8x squared. And then this is going to multiply by itself, so it's going to give you positive x to the fourth. And it's equal to 10. So let's see if we can solve this equation. First up, I'm going to reorder it so it's highest degree to lowest degree, descending order. And I'm going to combine any like terms like this 2x squared and this negative 8x squared. So that'll give us x to the fourth minus 6x squared. And while I'm at it, I'm going to subtract 10 from both sides. So that'll leave us with plus 6 is equal to 0. So if you think back when we were solving equations a few weeks ago, this is what's called quadratic form. So one method is, and I'll go through the whole thing, is to let the middle term equal u. So I'm going to let u equal x squared. That implies that u squared is equal to x to the fourth. Now the second one is only going to be used for the substitution. It's the first one that's really important. So this converts the equation into u squared minus 6u plus 6 is equal to 0. Now there's two ways of solving this. You can try factoring it, but that's not going to work. There's no factors of 6 that add up to 6. So the other two options are quadratic formula, and that I find takes a lot of time. I think it's easier because the middle number is even just to do completing the square. So u squared minus 6u, kick the other 6 to the other side, and leave a space. So the method is take half of negative 6, it gives you negative 3. Square it, you're going to add 9. And if you add 9 to the left, you have to add 9 to the right. Okay. So this turns our equation, I'll move it up here, into a perfect square, u minus 3 squared. It's always that half number that goes into this position, is equal to positive 3. And then square root both sides. Don't forget your plus or minus. And don't forget your square root. And then move the 3 over. So we're going to get u is equal to 3 plus or minus the square root of 3. Oh, this is going to be a fun answer. But we're not trying to solve for u. We were trying to solve for x initially. So we have to go back to this part of the substitution. Wherever there's a u, it's the same thing as x squared. So we're going to get x squared is equal to, I'm going to have to separate it, 3 plus square roots of 3, and x squared is going to equal 3 minus square roots of 3. And to solve for x, we're going to have to square root both sides of the equation. So I'm going to have to change things into decimals because we're going to get the square root of 3 plus the square root of 3 and the square root of 3 minus square root of 3. Don't forget plus or minus for both of them. So over here, after I square root and plus or minus it, I'm going to get a decimal. So let's see, 3 plus square root of 3. And then I want to take the square root of that answer. So it's about, I'll do to the nearest hundredth. This is 2.18. And then over here, if I do 3 minus the square root of 3, and then take its square root, we'd get 1.13. So this one will give me plus or minus 1.13. So those are all the x values. This one here, someplace in between those two, and then this one here. So the larger ones are going to be this negative 2.18, so that must be these guys that are further away from the origin. And then the 1.13 will be these guys here, which are closer to the origin. Now we just have to figure out what the y value is equal to. Now the easier of the equations to plug into is this one, because y is all by itself anyways. So if I plug in all these values into y, into this equation, I'd have to turn around and square these numbers. Now if I square these numbers, I'm back to 3 plus the square root of 3, and then I have to subtract 4 from it. So it'll be 4 minus 3 plus the square root of 3. That'll be negative 0.73. That would be this one here. So I would have the negative, oh, I'm sorry, I put in the positive one. So positive 2.18, so that would be over here, this coordinate, comma, negative 0.73. All right. If I put in the 3 minus the square root of 3, this guy, which would be the 1.13, so I'm looking for this coordinate, I would get 1.13 comma 2.73. So 1.13, 2.73. If I plug in the negative of this one, which would be, which would be when I plug it in as a negative number and I plug it in to this x, it becomes positive. So the y values are going to be the same. It's just going to be negative 2.18 and negative 0.73, which would be this point down here, negative 1.13, and then the y value would be 2.73. And then we're talking about this coordinate over here. So those are the 4 coordinates that solve this system of equations.